So now we talk about measuring resistance. In this case, it's the same connections as your current, your ammeter. Okay, it's the same thing, exactly the same. Just that instead of knowing your resistance now, because you want to find your resistor, this is why you want to measure resistance. You input a known voltage, you know your milliamp, and then you know your known ammeter ohms. Then you can calculate your resistance already. So this is how to measure a resistor. Alright. So in order to do that, let's see. Full scale is 1 milliamp. You have to ensure that your voltage, okay, input has has a value that will not, because if the resistance is, because based on V is equals to IR, right, and then V over R is equals to I. If the resistance, actually okay lah, no problem. So if the resistance is damn small, you can also still measure the milliamp in this case, right? Because the 500 ohm, because in series is 500 ohm plus certain X value of the resistor, right? So standard in a standard way, you would know that minimally you have 500 thing. So this is where it is. So you will not go wrong with it. So if you set as a 9 volt, okay, 9 volt divided by 500 equals to some values, okay, some values of X ohm. You reflect at here the at the 0 ampere. So if let's say, because the resistance itself, because it's hold on. Okay, so in this case, if you have a V over R equals to I based on the Ohm's law, V equals to IR, V over 500 plus some value of X ohm is equals to I, right? So if you input a 9 volt, alright, so 9 divided by 500, let's calculate. Here I have my calculator. It's like 0.018 ohms, I mean ampere. So at this point, the range is actually starting from here, 0.018 ampere. So if your resistance is going to increase, let's say 1000 ohm, so 9 volt divided by 1500, what do you have? I calculate myself lah, okay? You have 6 times 10 to the power of negative 3, which is 0.006. Okay, so 0.06 is maybe somewhere over here. This is the range. So you are going in this direction, right? This is 0. So as your resistance is getting higher, you'll go towards the 0 side. So you're gonna alter some voltages in this case, but they didn't draw it out over here. Right? They only say that there's a fixed voltage, but you may need to also have a certain amount of range of voltage in order to cater to different range of resistors that you are measuring. If not, you're gonna go way over the chart again. Okay, and why I'm going from the bigger number, okay, to a smaller number, it's because the resistor is connected opposite with the. I think you get what I mean. From the calculation, you know lah. So this is why. So the range is from 0 to infinity, right? Or in other words, from infinity to 0, because you are going in this direction. You are going downwards. As the resistor increase, your current is gonna decrease, right? As your resistor increase, if you understand, as your resistor increase, if the voltage is constant, you're gonna have a current that is going downwards, right? So this is why as your resistance, so let's say this is the scale from infinity to 0, right? So if your resistance is low, you have a high current, right? A high current, which is infinity current. And then if if your resistance increases, your current gonna decrease, so you're gonna go in this manner. So this is why multimeter is being connected in this manner. And then multimeter. One more thing. If you connect a 9 volt supply, you're gonna ensure you have a R in this case, because they didn't actually draw it out, right? So maybe I should draw it out over here. You should have another amount of R over here. This is actually called the R meter. Okay, what this R meter does is actually to ensure that the this scale is still from milliamp, 1 milliamp. Okay, so in this case, the scale goes like this: 1 milliamp, then to 0. Okay, so you'll go in this direction. Okay, from the largest to the lower. So if you have 9 volt, V over R equals to I. So if you have 9 volt, to ensure that you have 1 milliamp, which is 1, 2, 3, 0, you have 0.001, right? So you want to find your R, you have to have 9 divided by 0.001. In this case, you have 9000 ohm over here. So having this 9000 ohm, okay, allow you to have 1 milliamp over here as the set of range. And as the resistance varies, as this resistance vary, okay, you're gonna increase. Okay, let away that there's no 500 ohm over here lah. Okay, just take note. Yeah, hopefully you get what I mean, because you want to set this range, the highest range. So in this case, you're gonna have this calculation. So I don't know whether they really want, but this is a thing you need to understand before I go to multimeter. So let's go to multimeter now. Ta-da! Due to limited knowledge, I cannot talk about multimeter, but I don't think they will ask about multimeter, hopefully. Okay. If you want to remember, you can memorize how to draw this one. Okay. So if you want to measure resistance, you input a certain voltage. Then you have a certain multiplier over here to switch the amount of voltage corresponding to what I'm talking about just now, the R meter thing. Okay. So this is what I'm talking about. So this R meter, R multiplier can also be connected to your other stuff to ensure that you have you can calculate your emitter also. I mean your voltage also. So all in all, yeah, these are the things that you may need to consider. Then ampere wise, I don't know why you put an ampere over here. Maybe you want to I don't know. So yeah, I'll see you some other day for other things. But yeah, so hopefully I give you a good understanding of ammeter, voltmeter, and resistance. Multimeter, sorry lah. So what other stuff? I think chapter 3 sensors formula, you can go and watch the video. I have the sensor. And then chapter 4, what is the capacitance? So what inductor, right, you need to remember is actually voltage is equals to inductor current divided by time. Okay, this is the things that you need to understand. There's so many things talking about the inductor and such. Yeah, I think I'll just straight away go through, it's quite fast. So as the flux changes, the inductance flux changes, you induce a certain amount of voltage, you will increase the voltage. If a lot of flux, a lot of voltage. This is voltage, okay? And if there's a lot of change in the current across time, you also have a lot of voltage, okay? And then what is also want to say is that is the voltage leads the current. What does this mean? Okay, P is actually this green color P comes out first. Now my P is the overall circuit lah, overall signal. While E is the voltage. So as the voltage goes down, then the current goes down. You see, so the voltage leads the current in the sense. Voltage goes down, current goes down, and as the voltage goes up, the current follow goes up. So the voltage leads the current. This is what it's talking about. Okay, and then for capacitance wise, as the capacitance increases, your current gonna increase, and as the changes in the voltages increases, the current gonna increase also. So this is a capacitor. Alright, and then it's just saying that the current leads the voltage now. As the current goes down, the voltage goes down. across time, you can see. So as the current goes up, the voltage starts to go up also. So this is the few things you need to understand. And why is there changes in voltages will increase the amount of current? Because based on V equals to IR, V is proportional to I, if you remember. V equals to IR. So voltage is actually proportional to I in this case. So whatever changes in voltage, increase in voltage will actually increase in the current. Because normally if we say that increase in voltage will decrease the current, it's because the resistance is constant. However, if talking about AC, right, the resistance may not be the constant anymore. Alright, so yeah, anyway, then yeah, okay. So now don't want to confuse anything. So these are the things for chapter 4. And chapter 9 is the summation of whatever things I think I'll go through later. So see you there.